Yeah, hey and welcome my dear friends of the underwater world to a new tutorial. This time on the subject of Nitrox, and with it the question, can you really dive longer and deeper with it? I thought to myself, it's summer and one or the other of you may have just spontaneously made a diving license on vacation or was diving for the first time on vacation and then realizes that Nitrox might have been quite handy. That's how it was for me, and yeah, for this reason I would like to give you a little insight into the topic. A note right at the beginning: the tutorial does not replace a Nitrox course. Even though I try to cover everything important, this video is simply too short to replace a course. Also, I'm not yet a trained instructor. I would still appreciate your feedback, whether positive or negative. Write me in the comments or as a message what you think of the tutorial and whether it has helped you learn for the course or whether you have considered a course at all through the tutorial. To understand Nitrox, we first need to understand what air is composed of. It generally consists of 21% oxygen, 78% nitrogen, and 1% other elements and compounds that we won't look at it in detail. This is the real composition of air. There is another simplified composition. There, this 1% of other components is ignored, and we say air consists to 21% of oxygen and to 79% of nitrogen. And this simplified composition we consider. So when we talk about air in the following, please always have this tank in mind, whose content is composed of 21% oxygen and 79% nitrogen. Next, let's take a look what exactly Nitrox is. The name Nitrox is made up of the two words nitrogen and oxygen. I also abbreviate this to N2 or O2 respectively. Nitrox contains oxygen content higher than 21%, and therefore the nitrogen content is lower than 79%. There's another name called EANX, which means enriched air nitrox, where the X represents the percentage of oxygen. Common mixtures at dive centers are EAN32 with 32% oxygen and 68% nitrogen, or EAN36 with 36% oxygen and 64% nitrogen. To continue now, we need to understand the concept of partial pressure. If we look at a common tank filled with 200 bar, then this bottle is filled with 79% of nitrogen particles and 21% of oxygen particles. If we now separate these two elements, then the pressure exerted in each case would be reduced. In the bottle there would then only be the nitrogen particle or just the oxygen particles. That results in a lower and so-called partial pressure. This is important because some gases have different properties depending on the partial pressure. For this reason you have to be able to look at the partial pressure, and as an enriched air diver you have to be able to calculate it in a simple way. We will see in a moment how the numbers are calculated. Now let's take a look at how the partial pressure can be calculated. The formula for the partial pressure Pi is the multiplication of the volume share Y with the total pressure P total. The volume share is composed of the division of the partial quantity of the gas by the total quantity. This sounds very complicated at first, but we'll take a look at it right away. To understand and imagine the volume share, let's look again at our air-filled tank. We remember 79% nitrogen and 21% oxygen. To calculate the volume share of the nitrogen, we divide the partial quantity of the nitrogen, the 79%, by the total quantity, 100%, and thus get a volume share of 0.79. We proceed identically with the oxygen. 21% divided by the 100% gives a volume share of 0.21. By the way, the sum of the volume shares is always 1, which corresponds to 100%. To calculate now the partial pressure, we multiply the volume share we just calculated by the total pressure. We take a common tank which is filled with 200 bar, and the nitrogen share is now simply the previously calculated 0.79 multiplied by the 200 bar. That results in 158 bar, and the same is true for oxygen. Volume share of 0.21 times 200 bar is 42 bar. By the way, the sum of the individual partial pressures always results in the total pressure. But what exactly does Nitrox do? The lower share of nitrogen leads to longer no-stop times, shorter or not necessary deco stops, a reduced risk of decompression sickness, and shorter desaturation times because you take less nitrogen during the dive. This also makes Nitrox safer than conventional air from this point of view. Some also report less fatigue after diving. This is not scientifically proven, but should also be mentioned here. However, this varies from person to person. However, since oxygen is flammable, nitrox is also more flammable than air. Also, too high partial pressure of oxygen can lead to poisoning of the central nervous system. This makes calculations necessary before each dive and with each new tank, and your equipment must also be designed for the higher oxygen percentage. Let's take a short look at how a central nervous system poisoning occurs and its symptoms. It's triggered by an oxygen partial pressure that is above 1.4 bar. Possible symptoms are visual disturbances, ringing in the ears, nausea, dizziness, cramps and twitching, mostly in the face, irritability, restlessness, euphoria or fear. If you experience any of these symptoms, please end the dive immediately. We will now look at two calculations. First, we want to know the maximum depth we can dive with the common mixtures EAN32 and EAN36. The maximum allowed partial pressure of oxygen is 1.4 bar, and with EAN32 the volume share of oxygen is 0.32. We remember 32% oxygen share divided by 100%. We now convert the partial pressure equation so that we can determine the total pressure. We divide the permissible partial pressure of the oxygen by its volume share, which results in 4.375 bar. Minus 1 bar surface pressure, we get 3.375 bar of water pressure, which corresponds to a depth of 33.75 meter. The same applies to EAN36. The volume share is now 0.36. Here we also calculate the total pressure, again by dividing the 1.4 bar now by the 0.36, which results in 3.889 bar, and this corresponds to a depth of 28.89 meter. For the conversion of the pressure to the depth, I have made the assumption valid in salt water that 10 meters corresponds to 1 bar of pressure. The second calculation now deals with normal air. Here too, we first want to determine the maximum permissible depth. The allowed oxygen partial pressure remains the same and the volume share is 0.21. We again divided the 1.4 bar by the volume share of 0.21 and get 6.667 bar, which corresponds to a depth of 56.67 meters. This is beyond any limit of recreational diving, even as a certified deep diver, so please never dive so deep if you're not trained for it. Next, we are interested in what is the partial pressure of oxygen when we are at the limit of recreational diving, the 40 meters, as a trained deep diver. We simply multiply the volume share of oxygen by the water pressure at 40 meters, the 5 bar, and get 1.05 bar. Finally, a hint. Please keep in mind that every person reacts differently, so please dive like you have learned it in your diving course. Always dive conservatively and within your own limits to always come back healthy and safe from your dive. Yeah, and tech divers are sometimes exposed to a partial oxygen pressure up to 1.6 bar, but only during a deco stop. Here the science is not yet agreed, but for the sake of completeness I mention it briefly. The 1.4 bar are afflicted with a safety factor, which means that theoretically you could exceed this for a short time. You will learn about this in the Nitrox course. But I advise everyone not to do that. In technical diving, this is only done at the deco stop, where you don't or not move very much and only for a very limited time during the desaturation. Don't do this as a recreational diver. Yeah, and finally, we can now answer the two questions mentioned at the beginning. Can we really dive longer and deeper with Nitrox? We can only dive longer if we would reach our no-stop limits with air, and the breathing gas supply would still be sufficient. Deeper is definitively not an option, as we have seen that Nitrox can cause CNS poisoning under a certain depth. Yeah, at the end, I hope you had fun with this tutorial and learned something. I'm really looking forward to the exchange with you and wish you all time good air. Ciao!